Yeah, you heard it. That's good night, Irene. This is it. The last video. 7374, factoring those tricky polynomials and also the difference of squares. And we'll start with factoring 6x squared plus 13x plus 5. You note the coefficient in x squared is not 1, it's 6. So we have to use a different method for doing this. And the method I show in this class is by checking possibilities. So we start with possible factorizations that start out 6x plus something, x plus something. So we have 6x and x. They're going to multiply out to the 6x squared. And then we have two numbers here that are going to be the last product that will give us the 5. Well, two numbers that multiply 5, the only two are 1 and 5. So we have 6x plus 1, x plus 5. That gives us 31 x's. Way too many x's. The second possibility, when we multiply it all out, we get 11 x's, which is close, but no cigar. So we have to then look at possibilities that start out 3x and 2x. So those possibilities are 3x plus 1, 2x plus 5. That gives us the 6x squared and the 5. But when we multiply that out, we get 15x plus 2x makes 17x. Too many x's. Then the very last possibility here is 3x plus 5 times 2x plus 1. When we multiply that out, FOIL it out, if you will, we get 6x squared plus 3x plus 10x plus 5 gives us the 6x squared plus 13x plus 5. So that's our factorization. And I'm using Viking Purple here because my black markers are just about out. So, and I don't have time to get any new ones from Amazon or Walmart or any place. So Viking Purple today, 3x plus 5, 2x plus 1. Okay, here's one for you to try. Factor 3x squared plus 20x plus 12. So pause the video and give this one a shot. Okay, before we get too far with this, I'm going to look at the possibility 3x plus 12 times x plus 1. Now, if this possibility worked, we notice that this first factor has a common factor of 3, a greatest common factor. We could actually factor that first factor out as 3 times x plus 4 and then times x plus 1. But here's the thing. Our original trinomial does not contain a common factor of 3. And that's true for all these trinomials like this. If there's no greatest common factor in the whole trinomial, your factor itself cannot have a common factor within it. So the 3x plus 12 times x plus 1 cannot work. Your factor cannot contain a greatest common factor if the original trinomial does not contain a greatest common factor. So that rules out a lot of possibilities here on this problem. So keep that in mind. Factor cannot have a common factor itself within it. Okay, on to the other possibilities here. 3x plus 1 times x plus 12. If we FOIL this out, we get 1 times x, 1x, and 3x times 12, 36x. That gives you 37 x's, way too many x's. Now you notice I didn't list 3x plus 12 times x plus 1 because 3x plus 12 would have a greatest common factor. It cannot work. Okay, next possibility, 3x plus 4 times x plus 3. 4 times x will give you 4x. Then 3x times 3 gives you 9x, which would make 13 x's. Okay, that doesn't work. And here again, 3x plus 3, x plus 4 cannot work because 3x plus 3 would have a common factor. Okay, the last possibility, when we multiply out 3x plus 2 times x plus 6, we're going to get 2x's and 18x's. Because when we multiply this out, we get 3x squared plus 18x plus 2x plus 12, and that's the one that works. And here again, did not have to list 3x plus 6 or times x plus 2. Can't work because of the common factor. So this method, students don't like it, but once you get the hang of it and learn the tricks, it's actually the best method for factoring these. Okay, the next problem we want to look at is factor 12x squared minus 7x plus 1. Now, the minus 7x is significant because when we test possibilities, let's say 12x and x, we have to have a minus and a minus to give us the positive one. In fact, we have to have a minus 1 and a minus 1 to give us the positive one, but a negative number of x's. So 12x minus 1 times x minus 1, when you FOIL it out, you get negative 1x and negative 12x. Makes negative 13x's. Too many negative x's. And that's the only possibility we have with 12x and x. So then we have to go either to 2x and 6x or 3x and 4x. So why don't you try to find the possibility that works here? Okay, the 2x and 6x possibility, we have to have minus 1, minus 1. We end up with negative 6x's and negative 2x's when we multiply out, makes negative 8x's. Then finally, the 3x minus 1 times the 4x minus 1, we get negative 4x's, negative 3x's, makes the negative 7x. So this last possibility is the one that FOILs out and works. This next problem looks a bit scary because of these huge numbers. Factor 3x squared minus 301x plus 100. And you look at that and you think, whoa, how do I factor that? Well, first of all, we know it has to be 3x and x, and we know it has to be minus and minus. The two negative numbers are going to multiply to the positive 100 and give us a negative number of x's. So we know that. And we also know that 301 x's is a lot of x's. How in the world are we going to muster up 301 x's? Well, the only way to get those 301 x's is to put the 100 right here, which leaves the minus 1 right here. So some of these problems you just think, how do I get all those x's? How can I possibly get the x's from the numbers I put in? And putting the 100 there is the only way to do it. So that's the factorization. Okay, the next problem, factor 2x squared plus 17x minus 30. Now here we have to multiply it out to get negative 30 and a positive number of x's. Well, to get the negative 30, that means we need a plus in one of the factors and a minus in the other. So you're either going to have a plus minus or a minus plus. So you put in the numbers that multiply to negative 30 and find the combination that gives you positive 17x's. So pause the video, try this on your own. Okay, here's another case where just using some common sense can eliminate some possibilities. If we use the 30 and the 1, here in this first case we have 1x and minus 60x's. In the second case I put 2x plus 30x minus 1, I get plus 30x's minus 2x, which is still 28x's. Just too many x's. So the 30 and 1 cannot work. It gives you way too many x's, so you can just skip past the combinations involving 30 and 1. So then we move on to 2 and 15. 2 and 15 multiply to 30. If we put minus 2 plus 15, well, that can't work. Greatest common factor of 2. So we can't put the 2 with the 2x. That means the 15 has to go with the 2x. Remember I said the factor itself cannot have a greatest common factor because the original trinomial doesn't have a greatest common factor. So when we try 2x plus 15, x minus 2, we get 15x and minus 4x. And if we try 2x minus 15, x plus 2, we get a negative 15x plus 4x. That's negative x's. So neither of those work. So 15 and 2 don't work. So then we move to 3 and 10. 2x plus 3 times x minus 10. When we FOIL it out, we're going to get 3 x's. That's the inside product. And the outside product will be negative 20 x's. Added together makes negative 17x. That's real close. It's just off by the sign. So all we have to do is switch it to 2x minus 3, x plus 10. And that gives us negative 3x's, positive 20x's, add together to make 17x's. And here again, the 10 cannot be coupled with the 2x because that has a common factor of 2. So 2x minus 3, x plus 10 is our factorization. The last type of factorization is difference of squares. Difference of squares is a squared minus b squared equals a plus b, a minus b. So two squared quantities. So if I had x squared minus 4, that's really x squared minus 2 squared. So instead of a squared minus b squared, it's x squared minus 2 squared. We replace each a with x and each b with 2. So instead of a plus b, it's x plus 2, x minus 2. So see if you can factor x squared minus 25 on your own. Pause the video. It's very similar to x squared minus 4. So what we're really factoring is x squared minus 5 squared. So we get x plus 5, x minus 5. Okay, let's look at factoring 16x squared minus 1. The first thing to do when you're factoring difference of squares is to rewrite or at least rethink this as the two squared quantities. 16x squared is 4x quantity squared, and 1 is actually 1 squared. So here our a is 4x, that's what's being squared, and our b is 1. So we just replace a and b with 4x and 1. So our factorization is 4x plus 1, 4x minus 1. Okay, here's a similar one for you to try on your own. Factor 16x squared minus 9y squared. Give this one a try. So 16x squared is 4x quantity squared, and 9y squared is 3y quantity squared. I think you can see why we had to learn all those exponent properties. And so we just plug the 4x and 3y into our difference of squared formula. We get 4x plus 3y, 4x minus 3y. And that's all, folks. And we'll see you in the funny papers. That's it. Any questions? Post them in discussions. Any questions about anything?